Now let's introduce the UHV-1200 6-phase protection relay tester, produced by Wuhan UHV. This is the power line interface of our equipment. This is the power on/off button. This is the grounding port. And the 110 DC outputs and 220 DC output used to power supply for the relay protection tester. The row of terminals seen in front of the UHV-1200 is the 6-phase voltage and current output. We have UA, UB, UC and UA, UB, UC and 2 voltage common terminals. Here is our 6-phase current output, IA, IB, IC, IA, IB, IC and 2 current common terminals. Here is the binary input of our relay protection tester. There are a total of 8 binary input interfaces, including 2 common interfaces. Here is the binary output of the instrument. There are also 4 groups of binary output. Now let's look at the main interface of our software. The first is our universal test. There are 3-phase AC test, DC test and AC-DC test, as well as harmonic test, state sequence 1 and state sequence 2. Then look at our general protection tests. There are characteristic tests, frequency and high-low cycles, and power direction and impedance tests. Look at our line protection. There are group test 1 and group test 2, distance and zero sequence protection, and impedance specialty test. Element protection includes our differential protection, differential relay, and differential harmonic test. The auto mechanism includes our SAS test and our synchronism test. In our synthetical function, there are our 6 to 35 kV line protection tests, fault recurrence, delete para setting, and switch to 60 Hz software. Our commonly used tests include AC-DC tests, DC voltage, DC current, and AC current can be output in the test. Differential protection test is also a test we often do in element protection. This is also a test that is often done in relay protection. Now we do an overcurrent test of the relay protection tester. Now look at our DC 110V and DC 220V. This power supply is used to provide power to the relay protection tester. The lines we are connecting now are IA, IB, IC and the common terminal, as well as our trip signal port A and our common terminal. Among the 4 terminals here, the lower 2 are the power supply of our equipment, which is 220V DC, and the upper 2 terminals are the trip signals. The 6 terminals here are the IA, IB, IC, and the common terminals of IA, IB, IC. We connect the output to IA, IB, IC and short circuit the common terminal of IA, IB, IC to the common terminal below. Now we return to the test page of the software. We will do an overcurrent test. Click the 3-phase AC test. We can see that there are 3-phase voltages and currents. We only need the current. The overcurrent setting of the relay protection test of the test object is 5A. We set it to 4.7A. It can be set to change or not. We need it to be changed. The step is 0.1A. After the setting, we start to output current. The current output is 4.7A. We click the increase key 4.8, 4.9, 5.0. The relay protection tripping return action time, 198 milliseconds. The test is completed. Now we can see that our relay protection tester has occurred the action of current stage 1.